Hello everyone, welcome to Grade 12 Physics AP, Mastering Free Body Diagram in Minutes. In this video, it will be the introduction to this topic, as well as talking about equilibrium. So, what is a free body diagram? A free body diagram is a diagram that represents one or more objects, along with the forces in vectors interacting such objects. You can find an example of the free body diagram in this screen as you see now. A square block would represent such object. It can be any type of object. We could just draw a square block or rectangular block to represent it, and then the arrows would represent the vectors. So in this case, we have a object and in which the force of 5 newtons is being applied so that the block is moving or accelerating in the right hand side direction. So what is equilibrium? Well, equilibrium is a state in which the net force being applied on the object is zero. In a equilibrium scenario, the object is either at rest or in a constant velocity. It will not be in acceleration. So here are the steps for solving equilibrium problems. I would review this again in later videos. So generally it's very simple. You first draw the objects in any equilibrium problems as blocks, just to simplify the drawings. You could draw whatever that you want, but the standard convention is blocks. Then you draw the vectors, and it'll be the best to draw it in their x and y components. Sometimes these vectors might be in an angle. You could draw that, but also keep in mind that it'll be easier if you convert these angled vectors into x and y components. Then the next step is to put these vectors into two separate mathematical equations, one on the x-axis plane and the other one for the y-axis plane. The sum of all the vector components in the x-axis would be equal to 0. Also, the sum of all of the y components in the y-axis would be equal to 0. Afterwards, you would solve for whichever the variables that you have in these equations to find out the forces being applied on these objects. We will go over several examples throughout this course to make sure that you know how to tackle these problems. So let's go over a very simple problem. So for example, in a tug-of-war game, the person on the left pulls with a force of 10 newtons. What force must the right person pull such that they are at an equilibrium state? Which means that it would be balanced and it wouldn't go into one direction or the other. Okay, so here is the solution for this problem. Now, as you can see, the block represents the rope in the tug of war, and you have F1, which is the force that's pulling on the left direction, and F2 is the force that's pulling on the right direction. These forces are applied by the two boys in the tug of war game. So because that we only have the direction of force in the x-axis, we can only write one equation. So in this case, the sum of forces at the equilibrium state would be F1 plus F2 equals to 0. And if F1, as noted in our problem, it's 10 newtons, then in order for the sum to be 0, F2 must be negative 10 newtons. What does this mean? Well, as you can see, vectors have directions. So with negative 10 newtons, it just means that it will be in the opposite direction of F1, which is, instead of the left hand side, it will be applied to the right hand side. And thank you for listening to our video. This concludes the lecture. If you are interested in more studying materials, please download our physics app and other AP course study apps. This can be found in the links in our video description through YouTube. Also, if you want to keep up to date with our latest videos for studying purposes, please subscribe to our YouTube channel, and please share our videos via Twitter and Facebook. Thank you.